Okay, picture this. You wake up one morning, grab your coffee, and turn on a live broadcast from another world. You're watching kids run around on red dirt in these sleek, specialized suits, while right next door, scientists are pulling fresh, green veggies out of massive glowing domes. In the background, there's a spaceship just casually prepping for its routine trip back to Earth. Honestly, it sounds like straight up sci-fi, right? But this is actually a very real look at what humanity's future could be. Welcome to this explainer on the Red Frontier. Today, we're going to break down exactly what happens if humans colonize Mars and how we turn centuries of stargazing into literally our species' greatest achievement. So here is our literal step-by-step blueprint for how we're going to survive this. We'll start with a journey into space, surviving a hostile world, and securing power, water, and food. After that, we'll look at building a new society, how Mars biologically changes us, and finally, the ultimate choices this whole frontier demands. All right, let's dive right into this. Section 1, the journey into space, leaving Earth behind. Right off the bat, depending on how Earth and Mars align, astronauts are looking at a really daunting 6 to 9 months of deep space travel just to get there. That's up to 9 months of intense isolation, living in completely cramped quarters, all while getting constantly bombarded by dangerous cosmic radiation. It is the ultimate endurance test, and it happens before the mission even really starts. And we've got to understand just how completely different this is from what we do in space right now. Look at the International Space Station. If something goes catastrophically wrong up there, you're close enough to Earth that quick rescue missions are entirely possible. But deep space travel to Mars? That means total isolation and total self-reliance. There is no backup coming to save the day. Every broken pipe, every single medical emergency, it all comes down entirely to the crew's own skills and prep. Which brings us to Section 2, surviving a hostile world, the Martian reality. The reality of what we're actually up against when we land is just staggering. As you can see, the Martian atmosphere is roughly 95% carbon dioxide with practically zero breathable oxygen. On top of that, the pressure is so incredibly low that you literally cannot survive a second outside without a fully pressurized suit. Throw in winter nights that plummet to minus 100 degrees Celsius and huge dust storms that can black out the sun for months, and you quickly realize that every single breath you take depends entirely on advanced tech working flawlessly. So, how do we actually live in a place like that? Well, the first settlements definitely won't look like our neighborhoods back home. To handle that insane radiation and the freezing temperatures, early colonists are going to have to live in underground shelters or these highly advanced inflatable habitats. Engineers are even looking at bringing massive 3D printers to literally build structures using the local Martian soil, which is called regolith. Basically, think of these early cities as high-tech research stations connected entirely by sealed tunnels. Moving on to Section 3, power, water, and food, the survival triangle. Out there, water is going to be way more valuable than gold. Now, thankfully, we know there's frozen water beneath the surface and at the poles. But to survive long-term, colonists have to build a flawless, closed-loop water system. We mine the ice, melt and purify it, use it for life support and farming, and then, this is the absolute most critical part, we recover and recycle it. I mean, every single drop from washing, cooking, and even the moisture from breathing has to be captured and reused. And all that recycled water feeds directly into our next big necessity, agriculture. Shipping food all the way from Earth is just ridiculously expensive, so settlers have to grow their own crops. But Mars doesn't exactly have rich, fertile soil, right? So instead, they'll rely heavily on hydroponic and aeroponic farming. They'll use nutrient-dense water in tightly controlled labs to grow things like potatoes, lettuce, tomatoes, and wheat. Every successful harvest is a huge leap toward being totally independent from Earth. But you can't run water pumps or grow lights without electricity. The energy grid is gonna have to be practically bulletproof. We'll definitely use massive solar farms. But remember those dust storms we talked about? They can block out the sun for weeks at a time. Because of that, nuclear reactors and really advanced batteries are going to be a non-negotiable backup to make absolutely sure life support never goes dark. Next up, Section 4, building a new society, living on the red planet. The very first thing that's going to force this new society to become independent is the communication delay. Depending on where the planets are in their orbits, a radio signal takes between 4 and 24 minutes to travel just one way. Imagine trying to have an urgent conversation and having to sit there for potentially 48 minutes just to get a single reply. That agonizing delay means real-time problem-solving with Earth is completely off the table. Colonists will have to call their own shots, which is going to very quickly forge a totally unique culture and leadership style. Even the way they experience time itself is going to completely fracture from ours. A year on Earth is 365 days, but a year on Mars, that's 687 Earth days. Think about how much that profoundly shifts a society. Calendars, work schedules, holidays, when you celebrate your birthday, it all has to adapt to a uniquely Martian timeline. You're no longer living on Earth time, you are on Mars time. And the society built around that timeline will be incredibly specialized. Martian schools aren't just going to be teaching basic math. Kids will be learning critical survival and robotic skills from day one. In fact, children born there might only ever experience Earth's oceans and forests through virtual reality. Economically speaking, this society will eventually grow from a tiny research outpost into a massive hub for spacecraft manufacturing and deep space exploration, heading out to the asteroid belt and beyond.
Section 5. How Mars Changes Us. The biological shift.
The absolute anchor for this biological shift is gravity. Mars only has about 38% of the gravity we feel here on Earth. Now, in the short term, this means colonists will have to stick to rigorous daily workout routines just to fight off rapid bone loss and muscle weakening. Doctors and surgeons will even have to figure out entirely new ways to operate in a low-gravity environment. But what's truly fascinating is the long-term view here. Fast forward hundreds or maybe thousands of years, and scientists predict that generations born under that 38% gravity could actually develop noticeably taller body structures and totally different muscle development. Honestly, we don't even fully know how human reproduction works in Martian gravity yet. Eventually, Martians could develop such distinct biological differences that they wouldn't just be humans living on another planet, they'd actually be evolving because of it. Finally, Section 6, the ultimate choice, ethics in our future. Okay, so the cost to build a Martian settlement is going to be astronomically high. We're talking hundreds of billions of dollars. And that kicks off a fiercely valid ethical debate. On one side of the table, many argue those massive resources should be spent exclusively right here on Earth to tackle immediate pressing crises like climate change, poverty, and disease. But on the other side, advocates argue that expanding to Mars is an absolute necessity for humanity's long-term survival. They see it as an essential backup plan to protect our civilization from global catastrophes, like a major asteroid impact or a supervolcano. Both sides make incredibly strong points. But it's really important to keep in mind that this doesn't have to be a zero-sum game. Just the sheer intense difficulty of surviving on Mars is going to force us to invent some amazing new technology. We're talking ultra-efficient recycling systems, massive breakthroughs in renewable energy, autonomous AI, and highly sustainable agriculture. Those are the exact same tools we desperately need to improve everyday life right here on Earth. So the tech we invent to survive Mars could very well be what helps us save Earth. Then there's the wild card of what we might actually find when we get there. If we discover microscopic organisms already living beneath the Martian soil, we face a massive ethical dilemma. Do we strictly preserve those native ecosystems to study independent alien life? Or do we prioritize human expansion and risk contaminating the whole planet? It's a huge planetary protection puzzle that we have to solve before boots even hit the ground. Ultimately, the drive to colonize the red planet represents our absolute determination to push into the unknown. So the question I want to leave you with as we wrap up this explainer is this: are we truly ready to rewrite the history books and permanently divide human civilization into before Mars and after Mars? What starts off as a dusty little research outpost really could be the gateway to a completely new future for our species. Will we actually see it happen in our lifetime? Honestly, that is the most thrilling question of all.